This is my twist on a smart speaker with a retro look and modern upgrades. I wanted something that had that classic old school radio vibe, but supports streaming audio, Bluetooth playback, and being able to play songs locally from an SD card. You're probably thinking, why not just buy a ready-made Bluetooth speaker? Well, it's true that you can find tons of speakers being sold that support Bluetooth and SD card playback. There's virtually nothing in this form factor that lets you play an arbitrary audio stream. In a previous video, I built a decoding pipeline for over-the-air police radio traffic that I'm streaming across my local network. I just want to be able to listen to that on a simple standalone device. This is what I came up with. I didn't want to limit this device to just streaming audio, basically being a glorified police scanner, so I added support for Bluetooth and SD card playback. And the streaming audio feature can be used to play all kinds of internet radio streams. I'm going to give you a quick tour of this device, and then I'll walk through actually building it. It was a pretty awesome build, so I hope you stick around for that. Consider hitting that like button and subscribing if this sort of project interests you. Alright, I 3D printed the case on my Bamboo Lab P1S 3D printer. The case body is printed in a brown PETG or PETG, whatever you want to call it. And I used the fuzzy skin slicer settings to give it a nice textured effect, which does a pretty good job at hiding the layer lines. My favorite part about this build is the grill, which is printed in black PLA with gold accents to take advantage of the multi-material functionality of my 3D printer. I love how the little mostly badge at the bottom came out. It really gives it that retro vibe that I was going for. A cool feature of the grill is that it attaches to this black inner frame using magnets that I glued into the corners. They're attracted to the screws that connect the inner frame to the main case. This creates a really clean look with no visible fasteners. The inner frame is where the speaker connects to, and it's sunken down a bit to allow for some clearance between the speaker cone and the grill. I went with a really good quality speaker from Dayton Audio, which is definitely a step up from your average cheap project speaker. My second favorite part about this build is this awesome knob that I designed and 3D printed. I added knurling around the edges to give it a great feel in the hand, and I included gold accents to match the grill on the front. It took me a while to dial in the surface finish for the gold face of the knob, but I think it came out pretty great. The knob press fits onto a potentiometer that has an integrated switch, so turning it activates the switch and powers the electronics. You can hear the little click that it makes, then continuing to turn it adjusts the speaker volume through the potentiometer. On the back, we have a pass-through USB-C connector that powers the internal electronics. Let's plug it in and turn it on. I love the way the knob builds tension and finally breaks free, giving you that super satisfying click. Okay, this leads us to the modern twist for this project. On top is a 2.8-inch capacitive touchscreen that lets you control the various modes that I mentioned earlier. I designed this interface to have tabs on top for each one of the playback modes. First, we have a streaming mode for connecting to internet radio stations, or really any network audio stream. Let's try it out. It just comes and drifts away. I don't know how well this comes across in the video, but the audio quality is quite good. I'll move my microphone so you can hopefully get the full effect. Saw the sun in the distance look like a burning coin. Saw the sun in the distance look like a... Not bad, right? I built this pretty basic web-based manager interface that can be activated while on the streaming tab. This spins up a temporary web server where you can easily add the URLs for your audio streams. I figured this would be easier for entering addresses instead of using a small on-screen keyboard. Let's switch over to the Bluetooth tab. This lets you stream audio from a device like your phone, pretty standard Bluetooth speaker stuff. The speaker advertises itself over Bluetooth as mostly build speaker. Alright, there it is, mostly build speaker. Now I'll tap on it to connect to it. Nice, it's connected. Alright, here we go. Pretty awesome, right? Let's check out the third tab with the SD card icon. No surprise, this lets you play audio from the built-in SD card. I put together this simple player interface that currently just focuses on the basics. Let's take a listen. One issue I have with this is that it's pretty annoying to open the device to get access to the SD card. So I implemented this kind of cheesy web interface for transferring files to the SD card over Wi-Fi. I'd really prefer to have a USB mass storage mode, but the microcontroller that I'm using doesn't support native USB. A more simple solution might be to add a physical extension that exposes the SD card outside of the case, maybe for a V2 version. Like a mobile phone, I program the screen to dim after a fixed period of no activity and then turn completely off after 10 seconds. I have this set to dim after 60 seconds, but I'll use some video magic to cut right to that. Okay, so now it's gone dim, and any second now it's going to turn off. Alright, there we go. Then a tap on the screen, or turning the volume knob, wakes the screen back up. Because the screen turns off like this, I wanted some sort of visual indicator that the device is still turned on. So I added this light pod on the bottom that places 4 LEDs close to each edge, giving the speaker a kind of cool halo effect. Okay, let's get into the details of the actual build. First I'm going to cover making the case, and then we'll look at building the custom electronics. Finally, I'll assemble the speaker. I'll put links in the description to the actual parts and materials used in this build, as well as a link to the 3D models for the case. Like I mentioned earlier, I 3D printed the speaker case on my Bamboo Lab P1S. I ended up using a peanut brown PETG from Anycubic for the main body of the case. The variant on the right was printed in a matte brown PLA that didn't quite fit the aesthetic that I was going for. Initially I went with a smooth surface finish. It looks pretty good, but I wasn't a fan of the layer lines. Then I reprinted it using the fuzzy skin feature of my slicer, and I think it came out pretty awesome. Here's that matte brown version with the grill on it. It just feels too washed out in my opinion. I left the tree supports in here so you guys can see what it looks like right after printing. For those who don't know, supports are used when printing overhangs where there would normally be no material to build on top of. Adding supports creates a temporary structure that you can build off of, but easily snap them off when the print is finished. The speaker will be mounted onto this black frame that will screw into the case. Then the grill will attach using magnets glued into the corners that you saw earlier. It took me a while to dial in my printer settings for the grill. I got the best results from enabling the ironing slicer setting for the top surface. I also ended up printing the little Mostly badge as part of the same model rather than printing it separately and gluing it on later. Before printing the whole grill, I did some test prints on a corner section. On this top one, I tried printing it face down on my textured build plate. These two test prints show the difference with and without ironing the top surface. The one on the left that didn't use ironing has a lot of small gap-like artifacts between the holes. I did similar experiments with printing a portion of the badge separately as well. I ran some test prints using a model on MakerWorld to dial in the ironing settings for the filament that I used. I'll put links to the filament in the description in case anyone wants to try them out. I'd say the gold in particular was pretty great. I probably spent the most time designing the knob. At a glance, all the variants I printed look pretty similar. I really wanted to dial in a high quality surface finish for the gold disc in the middle. It took several tries, but I finally arrived at one that doesn't have any visible scarring lines and only has minimal defects where the print head started and stopped. I really like how the side gold accent lines came out, and the vertical knurling lines look and feel pretty awesome. What do you think? Let me know in the comments. I printed parts of the main case using some leftover gray filament just to get the measurements right before going for the full print with my peanut brown PETG. For the electronics, I designed a custom ESP32-based circuit board that plugs into a commonly available capacitive touchscreen module. I have this mounted in a jig that simulates the top of the speaker case and also keeps things orderly so I don't end up shorting something out. I sent out my circuit board design to be manufactured, and then I soldered all the parts myself. This part is a bit advanced for your average person, but because it's pretty interesting, I'll give you a short overview for how this went together. Let me know in the comments if you'd be interested in a more technical deep dive for how I designed the circuit board. I ordered a stainless steel stencil that allows you to spread solder paste over the PCB and deposit the paste perfectly over the surface mount pads. Then I painstakingly placed each component on the board by hand, using my homemade foot-activated vacuum pickup tool. And I used a handy color-coded diagram of the PCB and parts list. This is essentially how all modern circuit boards are assembled. Except industrially, they use super expensive machines to automate applying the paste and placing all the individual parts. It took me about an hour to get everything placed onto the board before I popped it into my homemade reflow oven. This oven heats the board based on a pre-programmed curve for the type of solder being used and the heat tolerances of the components being soldered. After a few minutes, the parts are all soldered and I'm ready to hand solder the through-hole components. Before doing that, I used this USB-C breakout board to test for continuity between all the pins. Any sort of rework on the USB-C connector would be significantly easier before soldering the legs that anchor it to the board. Everything checks out okay, so now I can knock out the hand soldering. In case you're interested, I'm using lead-free solder and my paste is also lead-free. In fact, the paste I use doesn't even require refrigeration, which is a really nice feature. Alright, let's put this thing together. The first thing we're going to do is melt in the heat-set inserts into the inner holes where the screen will attach, and also into the corners where the speaker frame will screw into the case. I'm using the short variety of M3 heat-set inserts because of the material depth that I'm working with. I'll link to them in the description. I also need to put some inserts into these little adapter bars, which connect the screen and custom PCB to the main case. I designed all these holes so the tip of the inserts will press fit in and be held in place, making it easier to stage them before melting them in. These inner inserts are pretty tricky because I can't get a proper vertical angle on them with my soldering iron. I'm carefully heating them with the edge of the ironing tip and paying really close attention so I don't tweak anything at a weird angle. This definitely isn't the ideal way to do this, but it wasn't that bad, and I managed to avoid melting the case by accident. Now I'll melt in the inserts for the speaker frame. These are easy because they don't have any vertical clearance issues. I love these soldering iron tips that are specifically made for heat-set inserts. I'll link to them in the description as well in case you want to check them out. Okay, now I can melt in the heat-set inserts into the mounting bars for the screen and PCB. These basically act like standoffs between the boards, and they have holes at the edges that will be screwed into the heat-set inserts on the inside of the main case body. I made this jig for the PCB initially so I could avoid working on it without the worry of shorting something out. I already have this wired up to all the components, and I crimped furls onto the wires to make the ends nicer to work with. Then I just tighten them down onto the screw terminals on the board. Let's move the electronics over to the mounting bars and install the assembly into the case. First, I'll screw the screen onto my mounting bars. Then my custom PCB presses into the headers on the screen and can be screwed into the heat-set inserts on the opposite side of the mounting bars. You could also attach totally different electronics to the pins on the screen as well. While I have free space in the case, I'll screw in the panel mount pass-through USB-C connector. Something super annoying that I discovered is that this connector seems to have the internal pins connected in a way that requires a specific cable orientation for the USB-C cable being plugged in from the outside. While this still technically works, it's pretty lame to lose the benefit of USB-C not requiring a specific orientation when plugging in a cable. This appears to be a common issue with these types of pass-through connectors. Okay, let's attach the screen assembly to the inside of the case. I'm staging my M3 screws in the corners before putting it in the case because it's so cramped to get a hand in there. Now I'll use a small Allen key to tighten the screws through the mounting bars and into the heat-set inserts in the case. Alright, nice. That was a little challenging, but it went pretty smoothly. I screwed on the potentiometer that pokes through the side of the case, and then I gently push this red status LED through a hole in the bottom of the case. This LED was intended to create a glowing halo effect under the case, but spoiler alert, I majorly miscalculated this one. You basically couldn't see any light coming from under the speaker at all. I went back to the drawing board and modified the bottom of the case to allow for a light pod assembly to be screwed on that would give me the glowing effect that I was going for. I designed the light pod to hold 4 of these sort of rectangular LEDs near the edges of all 4 bottom surfaces. I soldered 100 ohm resistors and wires to each LED while protecting any exposed wire with heat shrink tubing. Then I hot glued the LEDs in place and squashed the glue flat so the pod would sit flush on the bottom of the speaker case. This worked out well, but was quite cumbersome to assemble. If I was doing this again, I would probably design a custom PCB for it, which would significantly simplify the assembly. The light pod screws into the heatset inserts on the bottom of the case, and I tried to shape the case so that it sinks down a bit to make room for the wires that go to the LEDs. All the wires that attach to the PCB are managed by a row of screw terminals at the front of the board. Just like all the other wires, I crimped furls onto the wires for the light pod as well. Then I screwed the screen and PCB back into the case like I did before. The potentiometer shaft passes through the case and has a metal anchoring stud that goes into a small hole to prevent the assembly from rotating when you turn the knob. I snugged the retaining nut down carefully to make it secure, but also avoid cracking the case by accident. The USB-C cable that was already connected to the PCB plugs into the panel mount USB-C connector at the back of the case. Okay, let's connect our wires to the speaker. Earlier I crimped some audio terminals onto the wires that attach to the speaker using this cool kit that comes with multiple connector sizes. The two connector blades on the speaker are different sizes, so you really need two different size crimp connectors. Nice, I love that all this is easily removable versus being permanently soldered. As I put the speaker assembly in place, I'm trying to carefully position the wires inside so nothing gets kinked or pulled on. Now I can screw the speaker assembly to the main body of the case using some long M3 screws. These are intentionally not stainless steel, so the grill magnets will be able to stick to them. I countersunk the screw holes in the 3D model so they would sit flush with the speaker frame. To allow the magnets on the grill to make good contact with the screws, I made them stick out just a hair rather than having them be completely flush with the grill. They do a great job at holding the grill on there. I can't get it to fall off if I tip the case upside down, even if I shake on it. Pretty cool, right? The knob can simply be pressed onto the potentiometer shaft, and it just stays attached with friction. Nice, this is looking pretty great. I designed the 3D model to have little positioning dots on the bottom of the case to help orient the adhesive feet that I'm going to use. Before putting them on, I'll hit the surface with some isopropyl alcohol to clean off any contaminants so we get a good bond. These small rubber feet are from a company called Sound Addictive. They're a great size, slightly squishy, and the adhesive works really well. I think they look and feel great. Alright, that pretty much wraps everything up. I'm super happy with how this build came out. I love the retro look, and I'm pumped to have an easily customizable speaker that I can mess with. If you enjoyed this one, give the video a like and consider subscribing. Thanks for watching, and I'll catch you in the next one.